All right, time for another homework. And what we want to do is we use what we've learned so far, which is quite a lot, and we apply it to this simple destruction scene. Just a sphere crashing through a wall. As you see, every element of this we've already talked about, so it's your job now to bring everything together and create something similar to this. And as usual, the trick here is to try it yourself first. It doesn't matter if you fail or not, just do it yourself. You might even come up with a different way of doing it than me. The whole idea is to practice. And what you can use as a starting point is this scene that I uploaded. Nothing special, a little bit of light and some ground, and the wall the way we just saw in the last video. We take a single brick and then we copy it along a line with a little bit of a gap between. Then we offset that, and then we take the whole package and copy it up a couple of times, and what you get is a wall. All right, so this is a starting point. See you after the break. All right, so let's jump into the wall. And where do we start? We could start with the constraints, but in my case, I want to start, right away with the RBD bullet solver, so that we have a starting point and can test this at least. And what we want to try is to create a ground. There you go. And theoretically, this should fall apart, or it's fall down at least, and that doesn't look too bad. That's a good start. Now, of course, we don't want it to fall down. We want it to stay in place and being glued together. And for this, we can use the RBD constraints from rules, as we've learned, because this allows us to, connect any arbitrary piece like our bricks and create constraints between them. For this, you need the name attribute. So let's create that. And we wanted to do this anyway. So let's assemble our pieces here. And that will give us our name attribute that the RBD constraint from rules needs to find the connections. So let's actually check the constraints. And this time we were lucky that all the connections, you can see it, are there the way we want, so we don't have to deal with any settings yet. And one thing I want to do while I'm here using the assemble anyway, let's already pack the whole thing, because as we know, we will probably need them packed anyway. And the good thing is the RBD constraint from rules actually can work with packed geometry. So let's move on. Actually, while we're here, let's call this assemble. Let's give those bricks actually a prefix, which is brick. Cool. So let's see. We now have constraints. Let's take them. And the settings are not in here. So we have to create them, because if you would run it now, it will actually complain that there are no constraints on it. It would still work, but the constraints are not applied, and that's because the constraints don't know what kind of constraints there are yet. So let's use RBD constraint properties, and here we can say this is supposed to be a glue constraint. Sounds good. And the strength is 10,000, which is probably way too high, but let's run this to see if it holds. And yes, it holds together. Nothing happens. Well, actually there's a slight move downwards, and that is because it seems like the lower bricks still have a little bit of a gap in between the ground and themselves. But this is something that we have to solve anyway later on. I would say, sure, you can fix that, and we know how. Any wall on this planet needs some kind of foundation. So this is something we could create already. But before, let's start with something that will destroy it, because then we can judge better what kind of settings we need. So let's create some kind of projectile, some cannonball or something. And as usual, I prefer my good old polygons, because triangles are awesome. And I will now decide, as we talked about before, there are two ways of creating destruction here. We can either use an animated sphere, which has the advantage that it will not move at all, or we take an active sphere, which means it will react to the wall. And that's what we're going to do. So let's merge that with our active setup. And this one doesn't need constraints, so we can maybe connect it here, even though it doesn't matter. So now it's part of my active system. But of course, it's missing something, because this sphere, well, first of all, it's not properly positioned. So let's find a good position that we like and maybe make it a bit bigger. By the way, the scale of this whole thing, as usual, I keep forgetting it, is okay. It's not perfect, but it's also not outlandish. Pretty big bricks, to be fair, but that's fine. So the sphere should be about here maybe. and then we move it back, of course, and then it should crash through our wall. Now what I should do if I pack the bricks is also pack the sphere. Let's steal the assemble from up here. And now I get just 1 point. And when I run this, at least I should not get error anymore, and the sphere should just fall down. There you go. And something weird is happening. And this is actually something I wanted to show you later. What's happening? Well, as we've learned, if some objects are moving in the same way, even though they're not the same object, then that's a pretty good sign that something is wrong with our name attribute. And that's what happened here. You might have noticed it. The assemble node that I copied still has the brick prefix. So let's call this ball or something. So now we don't have two objects with the same name, which is always a problem. And while we're at it, let's make our sphere a bit nicer with a bit more subdivisions. And let's see what happens now. All right, that looks better. So let's give that sphere that is now packed and properly named some start velocity, probably with a point wrangle. Let's call it V right away. And that start velocity, you can't see it as usual, is actually positive Z this time. So let's say, I don't know, 10. Start with that. And let's see how that feels. That's not too bad, actually. And this is what I wanted to show you. The wall will fall down as soon as something, hits it. So 2 things. First of all, let me make the whole thing a bit faster. I like it to be having it a bit more oomph. There you go. That's nice. And actually the oomph is now so high that the wall is not actually falling over. Nonetheless, what we know we have to do here is deactivate the lower part. And for this, I create a point wrangle. And before I do anything, let's make sure we activate everything, because otherwise we will run into problems later on. Then I take a group to look for a specific point. Let's call it ground area or something. It doesn't matter really. To look for specific points at the bottom. There you go. And yeah, it's not easy to see, but there you go. Let's take the very lowest part. That's fine. And then for this group, we copy the active node and actually set the activation to 0, but only for the ground area. Or I should have called it foundation. And let's see how this looks like now. Yeah, that's much better. There's no wiggling in the wall because at the ground level, it's static. Now, as a base setup, we're done. As you can see, it doesn't look too bad and actually has surprisingly little problems. Nonetheless, a couple of things I would add to this, just to repeat it. The first thing is, let me work a little bit with the mass. So let's create another point wrangle and let's control the mass. And this, remember, very important, it happens to me all the time that I'm switching what object is what. This is now the mass of the sphere. So let's set it to, I don't know, 10 or something. And let's copy that. Oops, there you go. And now this is the mass of the bricks. So maybe 001. And this will not work. This will not change anything at this point. And the reason is currently our RBD bullet solver is not using mass. So let's make sure it's actually using mass and not density, which we're not using. And then it looks like this. And this is as expected. I have this all the time. As soon as I set the mass, the whole thing starts to behave completely different. Now, I can't fully explain to you why that is, but this is something I noticed. The reason is simple, that the glue constraint now is way too strong. So let's lower this. Let's maybe lower this to 10. And now that works. So let's increase it to 20 maybe. Yeah, that's not too bad. Maybe 30. Yeah, that still works quite well. Let's make sure actually by resetting the simulation, because maybe there's something else. No, it's fine. So now I can control the behavior with my mass by, for example, increasing the mass of the bricks. And you can see that here, the bricks are a bit more rigid and the sphere is slowing down a little bit more. So this is nice that now I have an additional way of controlling the whole thing. And maybe I lower the mass by halving the mass of the sphere, and now it should stop even earlier. All right, I think that's not too bad. You know, you can play around with the propagation iteration a bit more and stuff. So there are actually a couple of things that we can still improve on this, but we will look at this in the next couple of videos. For now, I want to finish this off by giving our bricks a little bit of a color. And we talked about this technique before. What we can do here is, of course, we can just use a color node, but the problem then is that each brick is then still, there you go, the same color, which is a bit boring. So let's make sure that each brick gets a slightly different color, and a technique I use for that is using a ramp from attribute, and I create my own randomize attribute in a point wrangle in this case, because the cool thing here is each brick is one object. So we can use a random attribute for each point by using a random function and then using the point number. If you have full objects that are not packed like here, you could use a connectivity node and a class attribute for the same function. And then here, the cool thing now is the rand function will assign any color from this ramp here based on this random attribute. Now, the best way to make this work is to unpack your pack geometry first though. So the randomizer uses the point number, so let's unpack afterwards, and let's just make sure that we transfer the random attribute that we just created onto the points. And now the color function, you can see, uses that random attribute to choose one of the colors here from this ramp. And all we have to do is now we find something that we like color wise. So yes, my colors look completely different in the example video. Fair enough. A quick note here, this is actually a pretty old school way what I showed you here, creating the random attribute yourself and then picking from a color ramp. The new attribute adjust color node has this functionality already built in. You just switch the pattern type to random, and then in this case we want it for the primitives of the color, and then you can see it already has this whole functionality built in one node. Just set it to random and then you can build your own color ramp. Let's quickly steal the colors by right clicking on the ramp parameter and copy parameter and then paste the values, and then we have the same values here. But by the way, you can also change this from color ramp to specific values, and then you can even choose from palettes where you can create specific colors that will be chosen for your random colors. So the new attribute adjust color node has all of this already built in a single node. But one last thing, what we can also do at the end, for example, is a polybevel. We will look at ways to do this in front of the simulation, but for now, this is an easy way of doing it. And actually the normals look a bit too soft, so let's recreate them. There you go, just to be safe. And this is what we got. And let's make the ground a little bit more orange as well. And it's not exactly how we saw it, but it's pretty close. And if you got something like that, then that's pretty cool. So yeah, this is all the things we've learned so far in a simple example. And the main idea here is not just to break up a wall, but to have control over all the elements and the behavior so that we can change it to however we want it to look like. So either way, I hope this is helpful. Thanks very much and see you later. Cheers.